All right, well, welcome everyone. Thank you for inviting me to speak for your group, Brian. I appreciate it. Session today is Understanding Dax. It's all about the context. This picture right here is courtesy of one of my friends who is an amateur photographer. So it actually has nothing to do with Dax. I just am showcasing her work for her. So this is a prairie dog out in the Rocky Mountain Arsenal area outside of Denver, Colorado. So just so you know. All right, let's go. Quick bit about me. Again, Angela Henry. I live in High Point, North Carolina. If you are unfamiliar, it is the home furnishings capital of the world, not just the United States, but the entire world. It says so on the sign as you drive into town. Just fun fact there. I am a solution architect for Blue Granite. Blue Granite is a modern analytics company. We do a lot of consulting. That's what we do. I am a data platform MVP and a Microsoft certified trainer. I am on Twitter. My handle is SQL Swimmer, and as you can see in that picture right there, I swim, but I'm also a coach and an instructor and an administrative official for USA Swimming. I'm going to get my soapbox out and say, if you don't know how to swim, please learn. It is the only sport that can literally save your life. And if you think as an adult you cannot learn how to swim, you are absolutely incorrect, because there are instructors like myself who are specially trained to teach adults how to swim, because it's very different than teaching children how to swim. So, and that's through US Masters, and you just Google US Masters and you can go out and they'll find an instructor that's close to you if you're interested. All right, I'm putting my soapbox away. Let's keep going. And now that you know a little bit about me, who are you? So if you put this in the Q&A, Brian's going to kind of hopefully help me out with this. I'm not used to using the Teams live version. I usually have like the chat going so I can see things tick by. So Brian, I'm relying on your help and assistance with this one. So are you a developer? Are you DBA? Are you an analyst? Or something I didn't mention? And I'm going to give you all, a couple of seconds here. I'm going to take a drink and see what we get kind of for responses. You have anything coming in?
Still waiting. See if anyone wants to use the Q&A feature.
Okay. And one of the reasons I ask this is because it helps me get a better understanding. So if a question is posed to me, if I kind of understand the audience that I'm talking to, it helps me frame your question better and give you a better response that's more targeted, and kind of understanding where your point of view, where that's coming from.
We have developer/analyst. Thank you.
Nice. Awesome.
We have analyst.
Very good. Awesome. All right. Very good. All right. So our agenda for today, we're going to do a quick intro on Dax. We're going to talk about filter context. We're going to talk about row context, and then what I refer to as exceptions to those rules. But first, if you've ever seen me present before, you know I have to take a picture, a selfie, with my audience, because nothing happens in real life unless you take a picture and post it on social media. So that is what I'm going to do right now. So bear with me for a quick second while I get my picture in here. Awesome. All right, and then of course we're going to post that on social media, because like I said, nothing happens in real life unless we post it on social media. All right, there it goes. Fabulous. So let's get started. Let's do that intro to Dax. No, not that Dax. This is so much funnier when I do this in person, because I see people just kind of shake their heads. For those of you who are unfamiliar, this is Dax Shepard. He is a comedian, very funny. I'm a very big fan. I actually like this Dax much better than the Dax we're going to talk about today, but that's beside the point. All right, so what is Dax? Dax is the language that is used in analysis services, tabular models, and in Power BI. And Dax is a functional language. And when I say that, a lot of people kind of look at me and they're like, well, what does that really mean? Well, what this means is that it uses trees of expressions to return a value, as opposed to procedural languages where you have a sequence of statements in order to get something done. So it works best if I show them side by side. So on the left-hand side, I have a procedural language, SQL, for example, where you have a sequence of events or a sequence of statements in order to do something. On the right-hand side, we have Dax, which is a functional language, and you can see that we have a bunch of nested functions inside those parentheses in order to get something done. So that's the big difference between Dax and procedural languages. And that's that nested trees of operations to get things done. So, well, what can we do with Dax? Well, actually, we can do a whole lot with Dax. Dax is a very, very powerful language. The first thing that we can do with Dax is we can define objects. So we can define columns and calculated columns to be more specific. And when we define those, they become persisted as part of a tabular query. So they're going to take up storage within your model, whether it be analysis services, tabular models, or Power BI. You can also define hierarchy levels. So these are the things that are going to help you organize your data and roll it up into your natural hierarchies for your businesses. And that's what kind of allows you to do your slicing and dicing for that. And then the last thing that you can define with Dax is your measures. And this is really where the magic happens and most of what we're going to be talking about in this session today. So the other thing that you can do with Dax is you can query for values. So if you have ever had to create perhaps a reporting services report on top of a tabular model, you have had to write a Dax query to get that back, to get that the data that you're looking for. And because you're typically dealing with aggregations and you're trying to analyze those results, they're called analytical queries. And when we talk about analytical queries, there are 3 different phases of those analytical queries. So the first phase is filter. And filter, that's what happens. We want to target the data that's relevant. We want to filter it down to only the things that we are looking for. So that's one phase. The second phase is the group. So that's where we want to dicing and grouping it into different results. So think of like a bar chart, all those different bars, that's grouping in addition to, if you add a filter, then you're kind of dicing it up as well. And then the last phase is that summarize. And that's where it's producing that single value result that we're looking for. And when you combine the different phases of an analytical query with the different types of objects that you can define in Dax, we see what we can do with each one of those. So if we look at those columns, those calculated columns that we created, we can filter those columns. That makes sense. We can group those columns. Yeah, that makes sense. And we can summarize those columns. Yep, that makes sense. When we look at hierarchy levels, we can filter those, we can group them, but we can't summarize. And that makes sense because they're not values that we're trying to get an answer for. That's something that we're trying to group by. So that makes sense that we can't summarize a hierarchy level. And then we have measures, and we can filter our measures and we can summarize those because these are those values that we're trying to get back, but we can't group them. We can't group those values together. And that makes sense too. So those are the different phases and the different objects and how you apply those to and this is all kind of setting the stage to help you understand Dax and evaluation context. And with evaluation context, we're going to get to this, but I just wanted to kind of introduce this. Evaluation context is made up of filter context and row context. When you combine those 2 things together, that gives you your evaluation context and how you come up with that final answer. So just kind of a quick summary on our intro to Dax. It's a functional language. We can use it to define objects, or we can use it for querying. And those objects that we can define, those are the columns, the hierarchy levels, and the measures. And our values are going to be determined by evaluation context, which is that combination of filter context and row context. I know that's a whole lot to kind of ingest there. So I'm going to take a drink and ask if anybody has any questions before we keep going.
There is one question. Where do calculation groups fall into this?
I call calculation groups kind of that special case because you can use them for all kinds of things. So when I think it kind of, I would really put it under that defining a type of object, because you can use that, you know, when Power BI, when tabular models first came out. So I'm an old school multi-dimensional model person. That's where I kind of cut my teeth when it comes to analysis. And one of the great things we had in multi-dimensional expressions in MDX is that we didn't have to create 30 different measures for time intelligence. We could create one, and then, you know, it worked for anything that we wanted to slice for. But when they came up with Dax, you couldn't do that. So you would have to create a measure for every single one. But when they introduced calculation groups back in, I'm trying to think, was it 2018? I think 2018 or 2019. I can't remember. You know, that allowed us to do that. But not only that, you can also do things like combining your static data with your more recent refresh data. So to me, that falls in the defining category, but it can also be used as a measure. So I'm not sure. That's actually a really great question. Nobody's ever asked that before. That's awesome. That's really made me think about that. Interesting. Okay. I don't really have an answer, but that's my opinion. If that matters. Is there anything else out there?
That makes sense. My first thought was maybe it's a measure, but it seemed a little more complicated.
Absolutely.
No other questions right now. Keep them coming if you have them. Okay.
Good. All right. Good deal. And Brian, please feel free to interrupt me if something, you know, if it seems relevant to what I'm talking about. I'm absolutely open to just interrupt me and let me know that I've got a question out there.
Will do.
Okay. Great. And I'm going to cross my fingers that my voice holds out. So I have horrible allergies and horrible asthma. And so this week has kind of hit me like a punch in the lungs. So I'm really hoping that my voice holds out for this session right here. Fingers crossed. I'm drinking a lot of water, so hopefully that helps. Pretty soon it's going to sound like I gargled with a bag of gravel, but I'm hoping it doesn't get that far. All right. So we talked about just an intro to Dax and what it is. Now let's talk about filter context. So before we can talk about filter context, we need to talk about the importance of a star schema in tabular models in Power BI. So Microsoft has embraced the Kimball methodology, which uses dimensional modeling. And if you're unfamiliar, that's based on Ralph Kimball's work, the Kimball Group, back in the 80s, where they came up with kind of the data warehousing scheme. And the star schemas were the big thing, the big takeaway. And I could go down an entire rabbit hole of dimensional modeling. In fact, I have a whole session devoted just to dimensional modeling. But I just want to kind of cover the highlights to make sure that we're all on the same page and kind of level set. So there are some vocabulary words that we're going to talk about. So we've got facts, got dimensions, star schemas, granularity, surrogate keys, and sentinel values. Those are the big, I think the big six when we talk about Kimball methodology and star schemas. Like I said, it's a whole rabbit hole that I could go down. This is my passion, but I just gonna very lightly scratch the surface here. So we have dimensions. Dimensions are those things that describe our business process. think of this as the nouns. So these are things like our customer, our date, our location, our category, our product. These are the things that describe our business processes. And this is what we usually want to slice our data by, our business process by. And then we have facts. And facts are usually, that's the business process. And they're typically very long, skinny tables in that they don't have a lot of columns, but they have lots and lots of rows. So they're these tall, skinny tables, you know, with millions, tens of millions, billions of records. Whereas our dimensions, those are kind of short, fat tables. So they hold all of the attributes about those things that we're trying to slice by. So a customer, you know, like a customer, their name, their address, their phone number, their birth date, anything, any attribute related to that. And those are short, fat, because you typically don't have a whole lot of rows in those dimensions, but they can get really wide. So those are those short, fat tables. And then our facts are those long, skinny ones that have lots and lots of rows. And then there's those relationships. So relationships really are what enable that magic to happen in your star schemas. And they're what allows that filtering and that slicing and dicing to happen. And it's because they have this directionality associated with them that allows those filters to propagate from your dimensions down into your fact table. And don't get me wrong, you can still create Power BI models using a singular flat file. You absolutely can. However, you're just going to make your DAX life more difficult. So my best bet, or my best advice, is to follow the Kimball methodology. The Microsoft analytical tools are designed to really be optimized if you're using that. So in short, star schema, all the things. Your future self will say, will thank you, as opposed to using a flat file for your analysis, because you're going to have to write significantly more complex DAX if you are using just a flat file as opposed to a well-formed dimensional model. Just some food for thought. Okay, so that is star schemas, dimensional modeling. That's our kind of little refresher, so we kind of level set and make sure that everybody's on the same page. So now we can talk about filter context. And remember how I said that those relationships, they propagate from the filters? This is what I was talking about. So filter context, that reduces the number of rows of relevance. So remember, that was kind of one of those phases of the analytical query. That's what filter context does. It filters down to the number of rows that are relevant, what we're looking for. And filter context is affected by your slicers, your filters, your visuals, and the interactions between those visuals. Now, there are lots of filter functions when it comes to DAX. I've listed some of them here. We are not going to talk about all of these because that's just way too much. But I wanted to kind of highlight the ones that I use on a very frequent basis. The all selected, the filter, and the remove filters. And almost everything I do, I will always use these 4 filter functions. I do use selected value quite a bit, but these are the really big ones right here. Now, the reason that this session came about is because I am terrible at DAX. I have been writing T-SQL code since the mid-90s. Way before Google was a thing. So my brain thinks T-SQL, it thinks in set theory. It does not think in DAX. So it's been very difficult to make that transition from, you know, thinking how I would get the answer with T-SQL to getting the answer with DAX. So I needed something very simple to be able to apply all of, you know, my filter context and my row context so that I could understand how all of this worked. So I chose my family because I know my family really well. You know, it's been a part of me for what, 52 years now. So, hey, so what I did is I pulled together some different attributes. So we're going to look at things like hair color. We're going to look at age. We're going to look at their driving ability, their swimming ability, of course, because I'm a swimmer. We're going to look at kinship. How are they related to me? We're going to look at location. Where are they located at in the United States? And the number of children. And we're going to start with my parents kind of at the top and then go with just from my parents down. So it's not my entire family, it's just from my parents onward. So when I modeled this out, this is what my model looked like. Those, remember, our dimensions are those short fact tables. So my location, my hair color, and my kinship, those are those short fact tables. Those are my dimensions. My family table, that's my business process. That's that long skinny table. That's my fact table. All right, so that's what my model looks like. And now I'm going to start with just 4 basic questions that I want to answer. So how many people are in my family? Who's the youngest? I was going to use the oldest, but it's my mom and she'd probably get mad. Although she does have Alzheimer's, so she probably wouldn't remember that she got mad. So it'd be okay, but I went with the youngest anyway. The average age, and then how many children? So those are the 4 basic questions that I want to answer. So let's start. So first, how many people? Well, I'm just going to use a very simple aggregate function called count rows, and I'm going to point it at my family table and say count the number of rows in my family table. And when I do that, I get 14. And I can count these here. There's 1, 2, 3, 4, 5, 6, 7 times 2, 14. I know I got the right answer. Very simple. The next question that I had was the age of the youngest person. Again, I'm just going to use a very simple aggregate function, the min function. And here I'm going to point it to the family table and I'm going to look at the age column. Now, if you're unfamiliar with Dax, the notation that I'm using here, those single quotes indicate that that's a table name, and the square brackets, when it's followed by something in those single quotes, is a column indicator. So I can look at this and say, what is the minimum age in my family table? And when I do that, it comes back as 1. That was baby Luca. He was born last summer. Is that right? Oh, almost 2 summers ago. So he's about 1.5 years old. So I'm just using whole numbers. So, and he's the one that's, I bet you can't pick him out, but I'll give you a hint. He's the one that's wearing the little bear suit. That's Luca. All right. Average age. Again, just using a very simple aggregate function that says, look at my family table and look at the age column and take the average. And when I do that, I come up with 32. Perfect. I don't know that that's correct, but I do know because I did an Excel spreadsheet to verify that it's correct. So, all right. And then my last question, how many children are there? So again, using a very simple aggregate function, the sum function, pointing it to my family table, looking at the number of children column and saying, take the sum of that. And when I do that, I get 12. Now, and that makes sense because remember, there were 14 people in my family and it started with my parents. So if you take those 2 away, that leaves 12. I got the right answer. Oh, yes, hallelujah. I always like it when I get the right answer, especially when I'm dealing with Dax. So to help you kind of hit this home, let's go over and let's start a demo and take a look at how this works. Now I have to switch screens here, so I'm going to stop looking at you all and come over here to my model. So this is my little family Power BI desktop model that I created. And, you know, if you pick somebody, it will give you their name, it will give you their relation to me, all that kind of stuff. So this is just something that I did as a side project to just kind of help me realize how stuff worked. So let's start by taking a look at the filter context. So I'm going to pull this out a little bit over here. And on the right hand side, we've got those 4 basic questions that we were trying to answer. The number of people, the age of the youngest, the average age, and the number of children. I've got some slicers over here. You'll notice that each one of these slicers is a dimension in my model. And just as a refresher, here's my model. There's our dimensions on the outside, and then there is our family, which is the fact table in the center. And we can use these slicers to filter down to the data of relevance. So if I click blonde, let's see how that changes the values for those basic questions. Look at that. It changes. If I go to brown, those numbers change. We're filtering down to the data of relevance. That filter is being applied to that hair color, and it's propagating because, remember I said those relationships had directions. You can see what those directions are, and from my hair color, it's going to go down to my family. So I filter my hair color, that propagates to my family table, and that's how we reduce it down to the rows of relevance. So slicers was one way we could do it. Another way was to use actual filters. So I can come over here and in my filter pane, I can say, okay, well, I only want to see people who have a driving ability of 4. Look at that. Again, my numbers change to those basic questions. I've got a table in here so you can see everybody, and it changes the pictures who are associated with that. And look, my bar chart over here, that's changed as well. So we can see how that changes. So that's our slicers and our filters. They've reduced those number of rows that are relevant to us. The other one was the interactions of the visuals themselves. So I could take this visual right here and say, I only want to see people from the Pacific Northwest. That filters this table right here. Changes the numbers over here. I could say who lives on the East Coast. I could say who lives in the Southwest. So it's very easy to see how we are filtering down to those rows of relevance and how that modifies the value that we get because we're just using simple aggregation functions. So with that, we're going to jump back to our slide deck and filter context. It reduces the number of rows that are relevant to us, and it does that with slicers, with filters, and the visuals. So we saw the different bars in the bar chart and the interactions between those visuals, and that is filter context. So do we have any questions about filter context?
None currently.
None currently. Okay. Well, then we're just going to keep going, and let's now talk about row context. Now, row context is a little more difficult to understand, and it took me a while to kind of make that switch and understand how row context works. So row context, that is created when you iterate over the rows to calculate the values that we want. And you're probably going, what? What that basically means is that we have to look at every single row in a table in order to get the value that we need to calculate. So how is row context created? Well, that is created when we use calculated columns. So remember, that's one of those things that we could define as a calculated column, or when we use an iterator function. And iterator functions are special versions of those. It's kind of a combination. I think of it as a combination of a measure and a calculated column all kind of rolled into one. And you'll see why when we get into the definition. And maybe that will help you. That's what helped me figure out what row context and iterator functions were doing. So firstly, we're going to create a calculated column. So what if I wanted to get a total safety rating based on the swimming ability and the driving ability? Well, that would be easy. I could just take the swim ability column and add it to my driving ability column, add those values together and create a brand new column called safety rating. Now, this is a calculated column, which means it's going to be persisted. it will take up memory in your model because it has to calculate that value, and it has to do it for every single row in your table. All right, so that's calculated columns for creating row context. Iterator functions. Again, lots of iterator functions. We're not going to talk about all of them, but again, I wanted to kind of point out the ones that I use on a very frequent basis. We've got average x, min x, max x, and sum x. And you'll notice these all end in x. That is your main indicator that these are your iterator functions. All right. So how could we use an iterator function? Well, let's go back and stop and think about that average, that safety rating. What if I wanted to get the average safety rating using an iterator function? Well, I can use that average x function, and I can say, look at my family table and add the driving ability to the swimmability and compute the average of it. So how you would read this is you're saying, look at my family table, add driving ability to swimmability, and then take the average. So it has to look at every single row that's in context and filter context to come up with that row context. I realize that's super confusing, and the first time somebody ever said that to me, I said, what? We'll see. It will make much more sense when we get to this demo right here. So before I jump over there, are there any questions out there?
Not right now.
Okay, awesome. All right, back over to the demo screen. So we talked about filter context. Now we need to talk about row context. Row context was the biggest thing that constantly threw me when I started working with Dax. And you'll notice I've got a whole bunch of stuff on here, but what I wanted to point out is I've got this table. It's got the name, the kinship, it has my driving ability, my swimming ability. It has that safety rating calculated column. So that's adding these two values together to create that calculated column called safety rating. And then there's that average safety rating iterator function. And then I created an additional calculated column called average ability. Now I didn't talk about this in the slide deck, but I want to show you. So first thing I notice is that, all right, well, these two in this column, these don't match. We're getting the average, but the numbers don't match. And when I look at my safety rating calculated column, and when I look at my average safety rating iterator, these do match until I get down to the bottom. And then this number over here, it's like, what the heck is going on? So let's start by just taking a look at the code behind each one of these. So I'm going to highlight this right here so that I can see where my functions are. And oops, I don't want that one, I want this one. And all right, so here is that safety rating column. Make this a little bit bigger. I'm just creating a calculated column, adding that swimmability to the drivability. That's what we saw in the slide deck. Then we've got that average safety rating iterator function. So let's come up here and take a look and see what that one's doing. That's using that average x function, and it says, look at the family table, take the driving ability, add it to the swimmability, and then take the average over all of the rows. So that makes sense because we have to look at every single row. That's why these are matching when we go row for row. But when we look at our totals down here at the bottom, we get completely different numbers. This is something that is, I guess it's kind of a double-edged sword. Whenever you create a calculated column in Power BI, the default aggregation is sum. So you have to be very mindful of that if that's not what you're trying to produce. So I could change the default value for this over here to be, I can change it Oh, is that the wrong one? There we go. See, it defaults to sum. I could say don't summarize it, or I can change it to average, minimum, maximum. I can change it to anything I want. But just beware that by default, it is sum. Okay, so that explains the difference between those two numbers because we were defaulting that. All right. And that average iterator function, that was saying add those two together for every single row and then take the average. All right, that's where that 4.9 comes from. It's adding all of these up, dividing it by 14, because remember there's 14 people in my family, and it gets 4.9. That makes sense. But where does this come in? Why is this? This is a really funky number. Where does this even come from? So let's take a look at that. So that is the averageability calculated column. So when I look at this one, look what I've done. I've said I'm going to create a calculated column, but what I want to do is take the driving ability, add it to the swimmability, and then divide it by 2 because I'm taking the average of those two values, and that's what it's doing for me. The reason that I did this is to just kind of show you the different things that you can do, and you need to be very cognizant of how you are creating your calculated columns and your measures so that everybody is on the same page and everybody understands what those values are. So there we are creating that row context. So watch what happens to all of these numbers when I start to filter, when I apply a filter context, because right now there's no filter context. And I know that because if I hover over any of my visuals here, let me see this one down here, I see this little filter icon, nothing is showing up. And same with this one, nothing is showing up, nothing is showing up, nothing is showing up. So I know that there's no filter context. But what happens if I say, let's go first degree of a relation? Now my numbers are changing. I've applied a filter context. Now these are the rows of relevance. So when I look at the row context, I first have to see what's in scope, what is in the filter context. Then I can go through and I can figure out row by row what needs to happen, and I can come back, and for my iterator function, I get the value based on that, and same for the average ability column. Okay, that makes sense. Same with, we're going to apply a different one, and our numbers are still changing over here based on, because we're filtering things again. Those are our 4 basic questions. That is, so we're looking at row context. We're changing the row context by filtering the number of rows of relevance that are going to be applied in that row context. So you see how filter context plus row context gives you the answer. So that is evaluation context. So with that, row context iterates over each row in order to be able to calculate the values that you're using. And row context is created when you use calculated columns or iterator functions. And that is row context. And if you felt like that was a whirlwind and you don't understand, you are not alone. Row context is a much more difficult concept than filter context. So do we have any questions out there, Brian, on row context?
There is one question on when you can use, it's sort of row context related. It's on when you can use a calculated column versus a measure, and it returns the same thing.
So when you can use a calculated column and a measure, and it returns the same thing.
Like in your example, the average function, if you just put that in a measure, I think they're saying that it would be the same value. Why do you need the row context in there?
So if we looked at my calculated column and my iterator function, is that what they were asking?
Yes. Mm-hmm.
Okay. So you could do it either way. the point I was trying to make here and why I did show this is because if you use that calculated column and you meant for the default aggregation to be average, it doesn't do that by default. By default, the average or the aggregator is sum. So if everybody is on board and everybody understands that safety rating calculated column will always be an average, then you can do that without having to use that iterator function. That's fine. It's just one of those things that can kind of come back and be a gotcha for you if not everybody understands kind of the rules of the game. So I'm hoping that makes it a little bit more clear.
Makes sense to me.
Okay.
No
All right.
other questions.
No other questions. Okay, perfect. All right. Well, let's talk about those exceptions. And I use kind of air quotes because they're not really exceptions, but I couldn't figure out a better word to use. So I use the word exceptions. So that is the calculate function or the calculate table function. I'm going to focus on the calculate function. And this is probably the single most powerful function in Dax as far as I'm concerned, because you can do anything with it. It allows you to modify your filter context. And it allows you to do that by either reducing the number of rows by adding new filters, by adding rows by removing filters, or completely changing the rows by modifying the filters that have already been applied to a measure. So let's see how this works. So if I want to reduce the number of rows, so what if I wanted to count the number of people with blonde hair? I can use this calculate function and I can say count the rows in my family table where hair color is blonde. So we're applying a filter in our hair color dimension and we're using that. It's going to propagate to our family table and then it's going to say count the number of rows in my family table where the hair color is blonde. So we are reducing the number of rows in that aggregator count rows. So that's one way to do it, to modify your filter context. We can add rows back. All right, so I had that number of people, right? Well, what if I want to count all of the people in my family all the time? So the number of people in my family never changes. It's always 14 unless we have a new baby, but it's always 14. But we saw how whenever we applied a filter context based on the dimension and attributes that we selected, that number would change. So we want to be able to add rows back in so that we always have the same number of people in my family. So we're still going to use that count rows against the family table, but now I'm going to use that function called remove filters. And what that does is it says, go out to my family table and remove any filters that are there, and then count the rows in my family. Now we are adding rows back. So if there was a filter context present, we've just removed it, and it will always give me that 14. So that's adding rows. Changing rows. So this is the big one. This is, what if for some reason we always wanted to know how many blonde people are in my family no matter what? So we've already seen how we can always get the number of people in my family, but what if we always want to get the number of blonde people in my family? Well, again, we're going to use that calculate function. We're still going to count the number of rows in my family, but now we're going to use this all function. So in the previous one, I used remove filters. In this one, I'm using all. Most of the time, you can interchange those two. The really big difference is that all can stand by itself, whereas remove filters cannot. That's the big difference. So I'm going to say I'm going to take all of the rows in my family table and then apply this blonde filter for hair color. So I'm completely changing the number of rows that are relevant. I'm saying if there are any filters applied to my family, throw them out the window, and now apply this blonde filter, completely changing it. So let's just jump over and take a look and see how this actually works. All right, so now let's come over to our filter modifiers using that calculate function. So here's the number of blondes in my family, and here's the number of people with blonde hair, and then here's the number of people in my family, and then this is just the number of people. So the ones in the blue boxes, those numbers should never change. Let's see if that's true. And if we can do that, I'll show you, because we want to, nothing up my sleeves. See, it's the same. That's what I'm doing, using that count rows inside that calculate, all family, hair color is blonde. And then if I look at, whoops, this one right here, same thing. We're removing those filters. All right, so let's start filtering and seeing what happens. Let's look at all of my sisters. Look at that. The number of blondes in my family didn't change, and the number of people in my family didn't change. But counting the people within that filter context did change. Only one of my sisters is blonde, and now there are only 2 people selected. So we modified that filter context for these 2, but we modified the filter context for these 2. For these 2, there we go. But we didn't for those. I'm hoping that's making sense of how I'm saying this. We can change it to look at my nieces. So the number of people with blonde hair, now there's only 2, but there are still 7 blondes in my family, still 14 people in my family, but now I have 3 people that are my niece. So that's how we can modify that filter context in order to get those answers that we're looking for. Calculate is a very, very powerful function that you can use to do that. All right. Oh, you know what? I wanted to show one last thing. So what happens if I look at this and I say, okay, well, now I want to see how many people are on the East Coast. Look what happens. Nothing. There's nobody on the East Coast. None of my nieces live on the East Coast. None of them have blonde hair. And there are no people, but I still have 7 blondes in my family, and I still have 14 people in my family. So that's filter context. That's modifying your filter context using the calculate function. So filter context plus row context gives you evaluation context. That's what gives you your answer. Now there's one more kind of exception that we're going to talk about, and I'm only going to lightly gloss over this because this is a much more advanced topic, and that is context transition. I just want you to be aware of it if you're not already. And what context transition means is that when you have a measure that's evaluated within a row context. When somebody first said that to me, I was like, what are you talking about? So you use this a lot when you want to bucketize values or when you're trying to compute a percent of total. So here's kind of a quick example. So here's one where I'm trying to bucketize something. I am using that measure number of children. I'm sticking it into a variable, and then I'm saying based on that variable, the number of kids, if it's 2, not so many. If it's 3, it's a few. 4, you get the idea how it based on the number, it provides an answer. So let's take a look at how that actually works over here in our demo. So this is our context transition. So I've got the name of the people over here. There's my number of children measure. Here, I'm trying to get a percent of total. So the percent of total children out of all of the children in my family. And then here I'm using those bucketized values to compare. So I have a row context. So I'm taking a measure and I have to look at it row by row in order to provide that answer. That's context transition. Like I said, I'm just lightly touching the surface on context transition. This is a much more complex topic and out of scope, but I just wanted you to be aware of that. So those are the exceptions that I talked about. Do we have any questions out there now, Brian?
This is back to the previous page on your slide. It says, how did the dad feel?
How did the dad feel? Well, I can tell you that my dad had 3 girls with her 3 girls, and I've always felt really bad for him. So that I can only that's my relevant experience there.
Makes sense. All
right, and that is all I had. This slide deck is available. It's out on my website at SQLswimmer.com. If you just navigate to the presentations page, just scroll down until you find it. You can download the slide deck, no problem at all. If you want to reach out and connect with me on Twitter, absolutely fine. If you want to connect with me on LinkedIn, I'm happy to do so. My only request is that if you do want to connect with me on LinkedIn, please tell me where you saw me. Being a woman in IT is sketchy sometimes. Being a woman in IT on the internet, it's very unpleasant sometimes. So if I don't recognize your name, I will not accept an invitation from somebody I don't know on LinkedIn. That's just the way of the world. So if you want to connect, I'm happy to connect. Just tell me where you saw me. I do have a whole bunch of references in here, so if you want to go a bit deeper, the definitive guide to Dax, I actually keep that over here, right? Oh my gosh, my whole stack of books. I highly recommend this. It's a very, very good book, written by Marco Russo and Alberto Ferrari, collectively known as the Italians at SQLBI.com. And another really good one is the SQL patterns or Dax patterns. This is actually available online for free. I'm very old school. As you can see, I have some little leaflets, sticky notes sticking out here on the side, and same with my definitive guide to Dax. I've got a bunch of sticky notes there. I'm just very old school. I like to be able to mark things up and have access to them. But I do have these references in here in the slide deck, so when you download it, you do have access to those and to get more information on that. And that's all I have.
Awesome. Thank you so much, Angela.
Absolutely.
Just a reminder, I did publish the link to our form to win an Amazon gift card in the chat. The different format from the previous months, just because we switched to Microsoft and added some questions there to help us out. So if you wanted to fill that out, we'd greatly appreciate it and try to bribe you as much as possible. So thank you so much for joining us, Angela.
Absolutely. Thank you again for having me. This was a lot of fun.
Yeah, it's an excellent session, and it's very easy to think you understand something in Dax and then go to dive in further and not know why it's returning the wrong number.
Just smack you in the face and say, Yeah.
All right. Well, thank you so much for joining us, everyone. And thanks again, Angela. And we will sign off for the evening.
Awesome. Thank you.
Bye, everyone.